Hi everyone, today me and my partner will be talking about collections. What is a collection? The collection in Java is a framework that provides an architecture to store and manipulate the group of objects. Java collections can achieve all the operations that you perform on a data, such as searching, sorting, insertion, manipulation, and deletion. Java collection means a single unit of objects. There are three types of collections. The first type of collection is a list. It is a collection of objects which can contain duplicates held in a specific order. The second type of collection is a set. It is a collection of unique objects in no particular order. And the last type of a collection is a map. It is a collection of unique keys and associated objects. Now let's start with lists. What is a list? Java List is an interface that extends collection interface. Java List provides control over the position where you can insert an element. You can access the elements by their index and also search elements in the list. This is an example of a list. It is a simple data structure that contains elements, and when it's needed, it can shrink and grow at any time. It is also the most common type of collection that is being used. Here we have an actual example of a list. Say you have a list numbers of 2, 4, and 3, and you want to insert a number between 4 and 3, and that number would be 7. So this is what will happen. Now let's move to sets. So what is a set? A set is a collection that cannot contain duplicate elements. It models the mathematical set abstractions. Two set instances are equal if they contain the same elements. So this is an example of a set. It is like a bag of objects rather than a list. It is based off a mathematical idea of a set, a grouping of members that can contain 0, 1, or many distinct items. Unlike a list, duplicate items are not permitted in a set, and a set does not arrange items in order. Though like lists, sets are resized automatically as items are added. This is an actual example of the set. Say you want to insert a number within the set, and an example with that number would be 5. This is what will happen. The number would insert anywhere. Many of the operations for a list are available for a set, but we cannot add an object at a specific position since in a set, the elements are not in order. We also cannot replace an item for the same reason. Though we can retrieve all the items, but the sequence is indeterminate, and it is meaningless to find what position an element is in. And lastly is the maps. So what is a map? It is an object that maps keys to values. A map cannot contain duplicate keys. Each key can map to at most one value. If you have used hash table before, you're already familiar with the basics of map. A hash table stores key or value in pairs in a hash table. This is an example of a maps. Maps are different from lists and sets because instead of storing individual objects, they store pairs of objects. The pair is made up of a key and value. The key is the red box shape that you see here. It is something which identifies the pair. And the blue thing is here is the value. It is a piece of information or an object associated with the key, and it can contain multiple pieces of data. It stores information relevant to the key. Take note that the key is unique and it cannot be duplicated, while the values can store multiple pieces of data. One example of the maps would be an address book, where the key would be the name of the person and the values are their address, phone, or email, and other information.
So, now that my partner has properly given us an intro to collections framework, we're going to take a look at how this is applied in JavaScript. So, there are various ways in which collections frameworks such as sets and lists are applied in Java. Among those are things like array lists, linked lists, hash sets, tree sets, hash maps, and tree maps. So, um, let's take a look at the first of these. So on the screen right now, you'll see a sample program of what is an array list. So the basics of if we review the basics of an array list, it is used to store multiple values to a single variable, similar to an array, except the main difference is that it can be modified, and um, you aren't constrained by you aren't constrained like a normal array where the size is set. So if you want to add and remove elements, you're able to with no problem. So now taking a look at our example array list, you can see that we've declared array list here as an integer array list as arly with the size of n, and since n has been n has been um, declared as 5, so the list is obviously 5. Using a for loop, we'll add numbers to the array from 1 to 5 to fill it up, and then it'll print the program will print out all the elements, and then the array list will actually remove the element number 3. So it'll actually reduce the size of the array by a whole element, which is something a regular array can't do because of the set size. After that, it'll print everything out and then print every element one by one with this second for loop. Now the output will look something like this, in which we have all the numbers, all the elements before when they were first entered, the element number 3, which is actually the number 4, removed, and then printing out the remaining entries there. So next we're going to take a look at the linked list. So the linked list implements the list interface. So as such, elements are not stored in continuous order. So even if you enter them in a certain order, you're not guaranteed that they will be sorted in that way. And it's called a linked list because elements are linked using pointers and addresses. Elements are called a node, and the addresses are what link them together. Because it's dynamic, there has a certain advantage over arrays. So, taking a look at our example linked list here, we can see that um, in our example program, the linked list string is declared, and we add elements which are not arranged in any order initially, adding letter A, B, and then you see the add last C, which will add the element C at the end of the list, and add first will add D at the beginning of the list, and then add two signifies the position of the letter E, so putting it in the second position. Now, um, the program will then print out everything, and then using the remove function, it'll remove B, remove element number 3, remove the first element and the last element, and then print out everything. And with that, we are left with this. Here's the initial linked list, the elements D, A, E, B, and C. We remove B, so that's gone. Remove element 3, which is E. Remove D, the first, and C, the last, and we are left with only A. The next type of collection framework we're going to look at is the hash set. Now, the hash set uses the hash interface and is a collection of items where everything is unique. So, in that sense, there is not necessarily arranged in order, but it can allow for things such as null entries, and um, but you can't have similar repeating entries since everything is supposed to be unique. So taking a look at our example program here, we can see that the hash set H is a newly created hash set and filled with elements. The following elements are Shadowbringers, Heavensward, Stormblood, and it adds entry Shadowbringers again. But since hash sets are elements are unique, it won't actually create another element. So right now the hash set only really has 3 because there can't be duplicates within it. So the program will then print the whole set, and using hrcontains, contains, it will determine whether the hash set contains the word entry Shadowbringers or not. Then using hremove, it will remove the entry Heavensward and display the list, and then it will show the remaining entries in the hash set, and the output will look like this. Here we can see the output which is the initial three entries in the hash set because of the condition in which there can't be duplicate entries. After which is the list. The list will check whether the entry Shadowbringers is there, and since it is, it enters true. There's the list after removing the entry Heavensward, and then here's the remaining list with the remain is it iterating the remaining entries in the list. The fourth and final entry we're going to talk about is the tree set. Now, the tree set uses a set interface as well. The main difference is that it does not retain insertion. It does not maintain the insertion order, but it will order elements using their natural ascending order, regardless of context or not. So, taking a look at our example program here. This is a very simple program. See the tree set string is declared, and then using ts.add, we add entries into it. Car, bear, and apple. Now, tree sets are similar to the previous entry. Duplicates are not duplicates will not be inserted. So even if we add tree set again and then print the whole tree set out, the output will still be only the three entries now arranged in ascending order of apple, bear, and car because that is a feature of tree sets.